up, guys? Welcome back to Guru the Guru. I don't know how your week has been. Mine has been great. A lot of learning. Just awesome and fantastic. I hope yours has been fantastic as well. So, today we're going to be looking at a single node installation for MySQL with Kubernetes. And this is a public repo that I have created for today's tutorial. So, you can check it out. So I'm going to put the link in the description down below, so you can just click on the link and you can go step by step with me. So I have a readme that explains all you need to do, so ensure you go to the raw one. So with that, what do you need? You need first a Kubernetes cluster. Nowadays it's quite easy. You do not need to have two virtual machines and then have one as a master and another as a worker. Just get a Kubernetes cluster from either DigitalOcean, Linode. There are quite a few. GCE, whichever you need, just find a cluster. And then have administrative rights to the cluster, and then also ensure you have kubectl installed in the cluster. I have added in the link to kubectl. Also ensure you check your distro. Could be Linux, could be MySQL, whichever it is, just check for it. So after that, we're going to create first of all, we're going to have a secret. This will store our MySQL secret. There is a password for our database. Then we create persistent volumes, and then we'll claim the volumes using persistent volume claims, and then we create a deployment, and finally a service, and that is all. Then we can access the MySQL and see whether our deployment works. So let's just get started. So I'm not going to be writing the code from scratch. All the files are provided for you in the Kubernetes cluster. So just go to it in my Kubernetes GitHub repo, the one I just linked below. So click down below and you'll get it. So the first one will be our SQL secret. So first of all, let me just clone this into my server. So I'm using Visual Studio Code and I'm on so this is just a virtual machine from DigitalOcean, but you could use Linode. I've used Linode a few times. They provide, I think, 100 credits. DigitalOcean the same, so you can just check which one works best for you. So let me just clone this. Clone. Clear. So you should get it somewhere. This one, MySQL, Kubernetes YAMLs. I've expanded this, so I believe it's visible. Just add one bit more. That should be alright. Let me just close that and have this one. So let me cd into that. MySQL Kubernetes YAMLs. And then you can see I have only 3 files: the secret, the storage, and then the deployment. So we're going to start with the secret, where we have our password for the database. So let me just go into that. Let me just show that. We'll explain it from the repo. It's a bit easier from there instead of going into Vim and all that. So let me open this in a new link. Let's open this in a new link. Let's open that in a new link. So the first one is a secret, and just as I'm saying, ensure you check first for the API version. What usually happens, all these are API resources from Kubernetes, so ensure you know the version. Again, all you need to do to check that is so what I've done is this VM is connected to the cluster, so I'm using this VM to access my cluster. So kubectl API resources, so that will give you the list of all the resources. So if we try to find let's try to find, let me just show you kubectl resources. Let me just find secrets. So you can see secrets, they're in version 1. So that is why we have API version 1, and then kind secret, as is always caps. Metadata is just where you give the name and the label, and you're done. And then the type, this is a basic auth, and then now the password. So this will be passed into our MySQL container. So let me just apply this one. So there are two ways you can either apply kubectl apply, kubectl create. So you can use either. So kubectl apply, you can use that, apply, and then the file, or you can use create and then the file. So my file is called SQL secret.yaml. So you should use that, and you should get the secret created. So kubectl get secret, because I know the name, just put there SQL secret, that is what I named it. So you can see the secret is there, created 17 seconds ago. So we already have our secret now. So what is the next step? We need to create a storage, the persistent volume and the persistent volume claim. There's a lot that goes into the persistent volumes, so ensure you at least take another look at them, not just copy and paste the YAMLs. So you can see, just as I've shown you the API version, how you find it, some are different. So but for persistent volume, it's on version 1. You give it a name. So the metadata API version, although they're usually common on most of the API resources, then give it a label, a type, and then ensure you have a storage class name. But for some clusters, all clusters have a default storage class name. So if you do not put the storage class name, it will just take the default one. But for mine, I have the manual one. Then the storage I want to set aside is 18 gig. Then it's read write once. So this means it's only accessible by one node. It could be a read write by many, RWX, or it could be a read only by many. So it could be either, and then you have the host path. So the different kind of you can use persistent volumes, you can use MTDIR. There are quite a few that you can try. So just check around from the Kubernetes documentation and see what you can use. But to avoid this, the applications living just like the pods, because for pods what happens is the stateful nature of pods when they go off or when they're dead, they go with their data. So ensure the data only lives as long as the pod. So with the persistent volumes, it ensures that the data will live longer than the pod. So if the pod die, the volume will still be there and it can be claimed. So you have your persistent volume, and then you go ahead and create your persistent volume claim. So all you're doing is claiming the volume, and I give this SQL persistent volume claim, and you can see the same access modes. So access modes, as I've said, they could be different. Read write one, it could be read write many, read only many. So there are a few. So you can see the resources I'm requesting. So what happens here, it will pick the resource that satisfies the 18 gig. So I've already put in the volume for persistent volume for 18 gig, so it will be able to satisfy the 18 gig. But if there are several volumes, it will only take the one that can satisfy the 18 gig. If there's one for 9 gig, there's one for 10 gig, it will only take the 18 gig or the 20 gig, depending on what you've provided. So let's go back to our server. Let me clear that. So you can have kubectl. Now this time we can use apply, so it's just the same. So SQL, they call it SQL storage or something. SQL storage, yeah. So you should have a persistent volume created and a persistent volume claim created. So if you do kubectl get PV, you should be able to see them there. So you have a storage class, we have SQL PV volume, this one here. This is what we have created with read write one. So only one pod can access this. And ensure also you have, let me just show that, ensure also that you have, let's find it. I just show it while creating the deployment, so you can see the volume that we created. So let's try kubectl get pvc, which is a volume claim. Oh sorry, that's below, so let me just get that pvc. So you can see the sql persistent volume claim. What volume is it bound to? SQL persistent volume. You can see access mode, read write once. So if you need any extra details, just add o/wide. So there's a lot we can do. So let's go ahead to the deployment, which is our final stage. And remember, this is a single node, not multiple node, single node. So on the deployment, we are creating the deployment together with the service. So not that. So that is where we have this, just as we had the persistent volume and the persistent volume claim. So you can see here. So you can see now the difference in the API version. You can just show that again. Let's clear that. kubectl API resources. But which one do I want? I want which one are we dealing with? Deployment. So if you get deployment, you can see the version is apps/version 1. So you can see apps/version 1. Then the kind, these one are usually common. So you give the name and give a selector. So the selector and the match labels will enable me to match it with the service. And also the strategy, ensure this is always recreate, because this is a single node, not a multiple node. So it's a single node, only recreate. Ensure that tag is there. And then up, and then you can see the image I'm using. So just containers, the image and the name, SQL, and then remember we had a secret. So this is where you pass a secret. MySQL root password. You remember the secret value from secret keyref. Remember our secret was SQL secret, and then the key is password. Remember we passed the string data. You can just show that. Remember we passed the string data and the key as password. So that is what we're getting here. Then you can see the port, the 306. So that should be common, and then the persistent storage, and then you can see where it's mounted. Just like a normal container for MySQL. That is where you mount your container. But now check the claim. SQL persistent volume claim. Just as we created a volume and then claimed it using the SQL persistent volume claim. So that is what we tag onto the claim name. So even if you kill this pod, it is able to get the data from the volume. So then the service usually enable us to access the pod. So you can see metadata, there's just the name. Then you can get the port. So this one is usually there, but sometimes you can use a container port. So it depends on what you want to use. And then you can see the selector app SQL. Just as we labeled it up here. So you have to give the app there so that it matches with these other ones. So let's just go ahead and run. So as I said, all these files are on the GitHub repo that has been published on the description. So just get the files and follow with me. So you can use create again. File. Sorry, what do I call it? I called it SQL deployment, I think. Yeah. So let's see if that creates. So we have the deployment. Let me just clear that. kubectl get deployment. So we ensure it's running. Deployment, here we go. SQL 1 of 1. So kubectl get service. So and most of the API resources have short forms. For example, SVC is for service, EP is for endpoint. My deployment is just deployment. So pod, you can have PO. So the short forms that you can use. Let's find that. You can see our SQL here. So now, since we have our secret, that is connecting. We have persistent volume that is claimed, persistent volume claim, and then after that we have the deployment with the service. So now what do we need? We need to access this container. So what do? I would like to clarify, first of all, the password complexity. Ensure it's 8 characters and does A to Z caps and lowercase. Just check the MySQL password complexity rule so that you do not get into trouble, because if the password complexity is wrong, you'll get an error when you try to log in. So I've run into that a few times before, so ensure you're able to catch that before you get into it. So let's just get the container. So you can see there, let's kubectl, get pod, and then SQL. Not MySQL, but SQL. So I called it SQL. So yeah, so you should get that. So now what do I need? kubectl exec it. I need this. So it's just the container ID, the pod ID, I should say, and then bash. Then now I need to go into, so this is the password for my root user. So you can see I'm in, so I can just do one command, databases, and that should be all. So you can see it's working correctly. You can just exit. Now you can use that database and exit again, then clear. So we are back there. So now you can see you have been able to create a secret, link that secret to a deployment, also have persistent volume and persistent volume claims to ensure that the data is not lost. So in case you would like to delete, I've also added that, but for any service all you need, or any API resource you need to delete, just do kubectl delete, and then the service name, for example pod, and then you could put that in there. But what will happen with this pod if we go back, kubectl get pod, let's see if our SQL pod is available. You can see 11 seconds ago. So what happened, Kubernetes is run on controllers, so the deployment controller will check if what the replica said, the deployment controller will check if its state is as it should be. So this said, this deployment for SQL provides that we have one pod, but the pod will not be available, so the state will not match. So what it does, it relands and creates the deployment and create the pod again, and that is why you see now the pod is 11 seconds old, although I created it some time ago. So yeah, that's all guys, and I hope you enjoyed this. If you have any comments, just leave them in the comment section down below. If you haven't checked out other videos, just click on the button up there. Good week guys, bye bye.